Given the series a sub n is equal to 1 over n squared, we want to find what value of n we can plug in so that our series error is less than 10 to the negative fourth. So to start this out, we will rewrite it something like this, so that the sum of the series is equal to the limit of that series as capital N approaches infinity, which is pretty much the same as the sum of the series n over n squared from 1 to capital N. So then we can also rewrite it to be such like this. Our original series will equal what we just had there, the approximation, plus the remainder. And then we can take that, the remainder needs to be greater than the integral of this one, so that's kind of the back part of the lower bound, we'll say, and this part, which is the upper bound. So that's easily visualized with a graph of rectangles and the curve approximating the area of those rectangles. One overestimates, the other underestimates, and together they actually, you can find the remainder from that. Or you can at least find that the remainder is greater than or equal to 1 and less than or equal to the other. So here we'll go that we want the error to be less than 10 to the negative fourth. So we'll take the integral from n to infinity of 1 over n squared dn, which will give us negative 1 over n is less than 1 over 10 to the fourth, and we'll do that evaluated between n and infinity. So we'll end up with this nice little guy right here. 1 over 10,000 is greater than, that's pretty much just 0 minus a negative 1 over capital N, which turns out to be 1 over 10,000 is greater than 1 over capital N, which the next closest integer for n, which is still greater than 10,000, is going to be 10,001. So that will be our minimum value of n, so that the error of the sequence 1 over n squared is less than 10 to the negative fourth.